Okay, the last section of chapter 2 of our trigonometry section is solving triangles. So this is basically putting all the concepts we learned together. So you learn about the sine, cosine, and tangent ratios. Remember, this is just an acronym, SOHCAHTOA, to remember that sine of the angle is equal to the ratio of opposite over hypotenuse. Cos of the angle, the reference angle, is equal to adjacent over hypotenuse, and tan of the reference angle is equal to opposite over adjacent. So depending on the triangle, you're gonna have to either use sine, cosine, tan, and if it's like a complex triangle which you have to solve every area, you might need to even use two of them. And then the other thing you need to remember is the sum of all three angles in a triangle and a right triangle have to always equal 180 degrees. So that's another concept you need to remember. And finally, Pythagorean theorem. So Pythagoras, a squared plus b squared equals c squared. And remember, c squared is always the hypotenuse, the longest side. Okay, so these three things you need to get down, and then you're going to put it together. So let's jump into the examples. So when you get a questions in this section, it's not only going to be sine or cosine or tan. It could be either one, or sometimes maybe even two of them. So you got to figure out which one to use, right? So how do you figure out which are you supposed to use, sine, cos, or tan? Just follow the steps. Remember, step one is to label the triangle. So when I'm labeling it here, let's read the question first, I guess. To determine the measure of indicated angle or side, which trig ratio would you use? Why? Then find the indicated angle or side to the nearest 10th degree. So to decide which trig ratio we're going to use, we're going to see what information do we have. Do we have the hypotenuse? Do we have the opposite side? Do we have the adjacent side? So in this case, looks like they want us to find out um, the indicated side of triangle. So I'm guessing they want us to find this side, or this angle, sorry. They want us to find Q, I'm guessing. Okay, so from if we're using Q as a reference angle, this would be the opposite because it's across from Q. Uh, Across from the right angle is always the hypotenuse, so the longest side is the hypotenuse, and therefore this Q, the other side next to the Q is the adjacent. Adjacent just means like next to, so adjacent. Okay, we labeled it. Okay, so what information do we have? We have the opposite. We have the hypotenuse. So I can even write a little thing. So hypotenuse, yes. Opposite, yes. So which trig function are we going to use? We're going to obviously have to use sine because sine involves the opposite and hypotenuse, and we have those two. So from this reference angle, we can simply say sine q, this angle, is equal to hypotenuse, oops, not equal to hypotenuse, opposite over hypotenuse, right? And then you can just plug in the numbers here. So we don't know what the angle is. So sine q is equal to 8 over 12, right? 8 over 12. And then from this point, whenever you're trying to find the angle, you're going to have to get rid of the sine, right? So whenever you're trying to find an angle and you have the two sides, you're going to use arc sine or arc tan or arc cos, depending on whatever you're doing. Remember that is, when I'm saying arc sine, it just means sine -1, right? So this will cancel out with this side. Then you have to do it to the other side. Okay, so what that looks a little bit cleaner is like angle Q equals arc sine 8 over 12, right? So from here, you have to plug this into your calculator, right? And then you should get Q equals 41.8 degrees. Okay. And if you don't get this on your calculator, it means that you're entering it wrong, or you don't have your calculator on degrees mode. It might be on radians, so just check that out. Okay, so I'm going to go a little bit faster than the next examples because they're pretty much the same idea, but we might be using cos or tan depending on the question. So here we're going to label the diagram. And it looks like we're trying to find side B. So from this reference angle, and across from the right angle is always the hypotenuse. This is going to be the opposite across from the reference angle, and this has to be adjacent. So what are you looking for? We're looking for the adjacent side. So adjacent question mark. We have the hypotenuse, and we have the angle, right? So I'll just write down C equals 34 degrees. Okay, so we need a trig function that involves the adjacent side and the hypotenuse. And from our acronym, adjacent and hypotenuse, we know we're gonna have to use cos law, right? Or the cos function, not the cos law. Okay, so cos, that's gonna call the angle theta. So cos theta equals adjacent over hypotenuse. And then just fill in the numbers here. So cos 34 degrees is equal to the adjacent side, which we don't have, so I'll just leave it as adjacent, over 6.4. Okay. And then now we're gonna have to basically isolate the adjacent side. So how do we get rid of the 6.4? We have to multiply 6.4 on this side. And you multiply 6.4 on the other side. And then if you do that, this crosses out. And then you're left with, I guess, adjacent. I'm just kind of moving over to the left side, equals 6.4 times cos 34. And again, I didn't put the time just because it's together here. It kind of means multiply. And then finally, adjacent, or B, I'll write it here. B is equal to 5.3 centimeters. Okay. Good. Okay, so let's move on to question C. Okay, same idea. Let's label the triangle first. And we have this reference angle, and looking like we want to find out what Z is here over here. So from this angle, this is the opposite. Across from the right angle is a hypotenuse, right? And then the side right next to it is adjacent. So what do we have? We have the opposite, and we're looking for adjacent. So what involves the opposite and an adjacent, right? So it has to be the tan function, right? So tan theta, because tan is opposite over adjacent. And then let's fill in the numbers. So tan 65 degrees is equal to the opposite, which is 12.1 over Z, right? And then finally we need to rearrange this. How do we get Z by itself? I'm just going to do the trick I kind of showed you a few times. So Z times tan on one side, so Z times tan 65, right? Multiply across this way, and then multiply across this way. So on the other side, multiplying across this way is going to give you 12.1 times 1, which is 12.1. Okay, and then what I would do is we want to get the tan away from the Z, so I divide by tan 65 on this side. And then I'm just showing you each step, but once you get used to this, you can just kind of skip this step. You don't have to show this as well. You could have just done it in one go all the way from here to down here. So this will cross out, and we're left with Z is equal to 12.1 divided by tan 65. And if you do that on your calculator, you should get Z to equal 5.6 centimeters. Okay, so this is nothing new. It's just combining, all the trig functions, so you got to figure out which one to use. Okay, part D is going to be the same sort of idea again. Okay, doing this one a little bit more quickly. Let's label our triangle here. So from the reference angle X, looks like we're looking for X, right? You know that this is going to be adjacent. Across from the right angle is going to be the hypotenuse, and this has to be the opposite, right? So what do we have? We have the adjacent, we have opposite. So adjacent, opposite, which trig function do we have to use? Tan, right? Because tan is opposite over adjacent. So tan theta equals opposite over adjacent. And again, we're using tan again because we have this information, we know, and we have this. We have the adjacent and opposite, so we're going to use those two. Let's just plug it in now. So tan x, angle x, is equal to 7.9 over 4.9, or sorry, 4.1. And to get we need to basically isolate this x by itself. So to get rid of this tan on the x, you have to do arctan, right? So tan -1, it cancels out. So we just have to do arctan on this side, right? So to rewrite it, it's going to be x equals arctan. And again, to get arctan button, it's like shift on your calculator or second, depending on which calculator you use. And then you just need to do that on this ratio. Okay. And you should get angle x is equal to 62.6 degrees. Okay, good. Next page. Okay, now you're going to get problems where you have to completely solve a triangle. So if it says completely solve a triangle or solve the entire triangle, it means find all the information about the triangles that's not given. So for example, we need to find out this angle, we need to find out what the hypotenuse is, we need to know what the adjacent side is. Well, I guess you really don't know if this is adjacent, but depending on what side. You basically have to solve all sides and all the angles. Okay, so how do we start this? There's many different ways to get the right answer. You don't have to follow exactly how I'm doing it. You can, you might do sine first and then tan, or you might find the angles first. So there's many different ways to figure it out. But when I look at a triangle, the first thing I would do is try to solve the angles first if I can. If I'm given two angles, I want to find the third angle because it's easy to do that because all angles in a triangle need to add up to 180. So let's do that first. So let's solve angle K. So you know that angle K is going to equal 180 degrees. Subtract minus the other two angles. So minus 90 degrees, the right angle, and minus 60 degrees. Okay. And if you do that in your calculator, you should get angle K to equal 29 degrees. So we already got one piece of information. So I got to write that in. And I might as well write the other information that's given. So angle J is 61 degrees. Angle L is 90 degrees. And what else are we given? We're given the side. So I didn't really talk about this either, but remember we talked about this is capital J, so across from it is lowercase j. So this is lowercase side j. It's also known as side KL. So you either see KL or J. So they're both, that's how you can label it. So here they just call it J. So let's put 6.7. Okay, now all we need to do is find K and L. So step 1 is done. So we're gonna have to do 2 more steps to find K and L. Let's just do side K first, okay? So you can use 2 different angles. So you can either start from 61 or we can start from angle K, which is 29 degrees. But another hint is always use information that's given. So I'll write that down. So try using info given. Okay, so why would I not use the 29 degrees here? Is just because, just in case I did this calculation wrong. So if I did this calculation wrong, that means all my other stuff's going to be wrong as well. So just to be safe, I'm going to use what was given because this one is for sure 61 degrees. So let's start from here. So from this angle, 61 degrees, this is the opposite, right? And this is the adjacent side, right? If you're using this angle, okay. And this is the hypotenuse, okay. And we're trying to find K, and side K is the adjacent. So adjacent and opposite, we're going to use tan here. So let's just plug it in. So tan 61 degrees is equal to the opposite, which is 6.7, over the adjacent side, which we don't know. So I'm just going to leave it as side K, right? So from here, what you got to do is isolate the K. So you can multiply across. Okay, so K times tan 61, oops, is equal to 6.7. So again, how I did that from here is I did K times tan 61, K times tan 61, 6.7 times 1 is just 6.7. And now I'm going to divide this side by tan 61. I'm going to divide this side by tan 61. And I'm doing it in a couple steps. And again, you could do this in one step, but I'll just go step by step so people don't get confused. This crosses out, and to rewrite it, I'll just do K equals 6.7 divided by tan 61, right? And from here, you just put this into your calculator and you'll get K equals 3.714. Okay, so we got that. So we can add that to our list of items that we've solved, 3.714. Okay, and the last step is we need to find out the L, right? Is it an L? Yeah, it is an L. So the hypotenuse. So we can just continue using with this angle. So if we were looking for the hypotenuse, so remember we're trying to look, I'll even write this down. Sometimes it helps to write it down. So what is the hypotenuse if we're looking for this angle? What information do we have? Remember, we're going to use what's given. So what's given was the opposite. So we have opposite, right? Technically, we just solve this again, but you want to use the value that's given just in case we did this wrong. So 6.7. And yeah, so what involves hypotenuse and opposite? And you're going to know it's sine, the sine function. So from this reference angles that we're looking at, we're doing everything from the perspective of 61 degrees. So sine 61 degrees is equal to opposite over hypotenuse. Opposite is 6.7. And hypotenuse we don't know, so I'm just going to write down L for hypotenuse. And now we're just going to rearrange it, just like how we did over here. So this is what I mean by one step. So I know I'm going to put this up here and then bring this down here because this is over 1. So instead of doing the 2 steps, I can simply just write down L equals 6.7 over sine 61. Yeah, kind of forgot what the angle was. Do that in your calculator. You'll get L equals 7.6, I believe, 61. Okay, so we'll just do that. Okay, 7.61. Okay, and now we have all the information. That's how you completely solve a triangle. And just note that you didn't have to do it this way. You could have, oops, let me just zoom out so you can see the whole thing. You could have done, for example, once we have one of the sides, and then you could have used Pythagoras theorem and just done a squared plus b squared equals c squared. We could have done, this way first. We could have done sine 61, then done this, or there's tons of ways to do this question. But all right, let's move on to the next page. Okay, so this question is similar to the last one, but the difference is there's no drawing for us and there's no inventory list. So what do we do then? We basically just draw it out and make an inventory list, right? So let's draw out the triangle first. So it says in right triangle, triangle KMN, and this just means triangle with angles KMN, right? Angle M is 90 degrees, side KM. So when you have KM like this, it means the side between the angle K and M is 8 centimeters, and the side between angles M and M is 9 centimeters. Solve this triangle, give measurements to the nearest tenth. Okay, so let's draw it out. And the drawing's easy because we know we're just dealing with right triangles. So when you get questions like this, you can just draw a right triangle out. Right? If you have a ruler, you can use a ruler. Otherwise, you're going to get this little thing like that sometimes. So, okay, so it says angle M is a 90 degrees. So we can simply already write M here. Does it give us any other angles? No, so it just gives us some sides. So it doesn't really matter what you label K and N. Just I'll put K here. Could put N here. You could have done it the other way around. So let's label the sides here. So K and M is 8 centimeters. So between here, so we know that this is going to be 8. And I'll leave the units for now because just makes it a little bit more clean. But make sure you put the units when you do your answers. And it says and between M and N, so side MN is going to be 9 centimeters. Okay, so there we go. We're pretty much done our drawing. So what do we need to solve? We need to solve the angle here. We need to solve the angle here, angle N. We need to find this side. Those 3 things we need to do. So just notice that we only have one angle, so we can't use 180 minus the 2 sides because we only have one angle. But what we can do, I already noticed, what can you do if you have 2 sides and you want to find the third side? You simply just use Pythagoras theorem, right? Hopefully you said that. Okay, so let's make an inventory list so we keep organized. So angle K, we don't have. And angle M, we have is 90 degrees. Oops, my phone. Okay. Angle N. We don't have either, so I'll leave it blank. Side. I guess we do have. We'll just label this as N, I guess. So N, even though is 8 centimeters. Side K is 9 centimeters. And this side M, lowercase m, right, across the hypotenuse, I guess, is we don't have. So we got to solve these three things. So first thing I'm going to do is solve the hypotenuse because Pythagoras theorem. And let me just change my view so you can kind of see. Okay. There we go. So Pythagoras theorem, a squared plus b squared equals c squared. I'll write that out just so you guys remember. Okay. And then finally, just plug in the values. Doesn't matter which one you call a or b. So 8 squared plus 9 squared equals c squared. Okay. And then do a little of math here. So 81 plus 81 plus 64. I'll just do this in my head. Is 145. So I skipped a couple steps because I'm writing really big now. So 145 equals c squared. And again, remember to get rid of the square, you're just gonna square root both sides. So you're gonna square root this side, square root this side. These cancel out. So we get c, which is, remember c is actually the m because we're doing the hypotenuse is 12.04 centimeters. So go back to our inventory list. I can write down 12.04. And now we just got to find out angle K and angle N. And here we can just write, we can use either the tan or sine and one of the trig functions. So let's do part 2. And I'll zoom in a bit because it's kind of can't see. Okay. So here, for the tan function or the trig function, and I kind of already said tan because that's what I'm going to be using, is we're going to be using the tan function to solve side K. Okay, and maybe I'll draw the triangle again here. I'll pause and just draw it out here. Okay, just like magic, it's there now. So we're going to try to find out angle K over here. And just remember, angle from this perspective, this is the opposite from this reference angle, and this is the adjacent. So simply tan angle K is opposite, which is 9, over the adjacent, which is 8. Okay? And from here, you're just going to basically get rid of the tan and put it on this side. Remember, the opposite of tan is arctan. So arctan this side and arctan this side. And I'll write out again. So -1, this cancels out. Arctan on here. So we get K to equal arctan 9 over 8. Right? And if you do this in your calculator, you should get K to equal 48.4 degrees. Okay, and then we can add that to our list. 48.4 degrees. Okay. Yeah. So let's do the last side. So now we need to, and I'll do this one. I'm running out of space here, so we're gonna do this side here. So angle N, and angle N we can find out a few different ways. So the easiest way, since we're also running out of space, is we can just simply do 180 minus the two angles because we already figured out K. So 180 minus 90 minus the angle K we just found out, which we just said was 48.4 degrees. And then finally you get angle N to equal 41.6 degrees. And this is the angle side. Okay, so there we go. So now we can put 41.6 degrees. I know this is kind of all over the place, but I'll post the notes, and the notes will be a lot more organized when I upload it. Okay, so there we go, and there's our answer, and we solved the triangle. So next page, let's go. Okay, so technically that's all the information you really need to know in this chapter. But there could be questions where you get compound triangles, two triangles together, or word problems that might be tricky, but they're basically all you're doing for all these problems. Just remember SOHCAHTOA, remember Pythagoras theorem, remember what the words equilateral, isosceles, and scaling triangles are? And if you forgot, equilateral triangle just means triangle where all sides are equal. Isosceles triangle is when two sides are equal, and scalene triangle is when no sides are equal. So that you might need to know that depending on the word question. Horizontal line, remember horizontals go like left to right. The x-axis, vertical just means up and down, like that. Okay. And maybe I'll provide the definitions on the notes or the uploaded notes. Okay. So we're just gonna move on. Some other terminology you should remember is when it says angle of elevation, it means going up for the horizontal. So this is a horizontal line, and you're looking upwards. So this is the angle of elevation. Okay. When you're saying angle of depression, that means going down from the horizontal line. So when you're looking down, this angle over here. Okay. Angle of depression. Okay, let's just start with these questions. Whenever you get word problems, the first thing you want to do is draw it out. Always draw out the triangle. And then from there you're gonna label the triangle. And from there it's gonna be like any other question that you had in trig. So here let's do this one. Standing 250 meters from the base of a cliff, there's this 31 degrees angle from the feet to the top of the cliff. So already I can see it's like an angle of elevation. You're gonna be looking up because you're standing at the base and you're looking at the top of the cliff. So how tall is a cliff? Okay, so already you can say, okay, here is my cliff, right? I kind of drew that a couple times. So, and let's go down. And this is where the little dude here, my hand is getting a little sweaty. So little dude here is looking up, right, from this angle. And there's a line. So standing 250s from the cliff. This is the cliff, remember? So I'll even write it. Cliff. Okay. He's standing 250 meters from it. Okay. There's 31 degrees angles from your feet. That's why I drew at the bottom, not to his eye. So from his feet to the cliff. So this angle is 31 degrees. Right? And it's saying how big is the cliff. So this is what we need to find out. There we go. So we have an angle, we have a side. So if this is a reference angle, you know that this is going to be the adjacent. This is the hypotenuse, which we don't really care about in this question, but I'll label it. And this is the opposite. So we're going to use the adjacent because we have that information, and we're going to use opposite because that's what we're looking for. So what trig function do we use adjacent and opposite? We're going to use tan, right? So tan from this reference angle, 31 degrees, is equal to the opposite, which is we don't have. I'm just going to call it x, and over the adjacent side, which is 250 meters. Okay. So you should know how to rearrange this. So we want to isolate the x. So this is dividing by 250. So I'm going to multiply it by 250 and multiply this side by 250. So it's going to be 250, 10. Oh, I said tam. Tam is not a function, trig function, equals x. Okay, now put this into your calculator. X equals 150.2 meters. Okay, and it's a word problem, so I guess you need a word sentence answer. So the cliff is 150.2 meters tall. Okay. Okay. There we go. And I usually just circle my stuff so the teacher can see. Okay. Next question. The Douglas fir tree, 85 feet high, casts a shadow of 47 feet. What is the angle of elevation of the sun? Okay, so let's draw this out again. First step. So Douglas fir tree. So pretty big tree, 85 feet. Okay, now let's leave the units for now and just add at the end. What else are we given? So we saying cast a shadow. So you know shadows are on the ground, right? 47 feet. Oh, I guess I might as well put the units now since I did. And then it says, and we know we're going to do a right triangle, so you can already connect it, right? So what is the angle of elevation of the sun? Okay. So this question might be kind of confusing because you may like, what is Like, where does the sun come into this picture? And the sun is actually over here somewhere, right? So this might make the picture a little bit more confusing. The sun is over here. It's coming down and it's hitting the tree, and the tree goes downward and it casts this shadow, this long shadow, right? So what is the angle of elevation? The angle of elevation is just this angle here, remember, from the horizontal upwards. So it's asking us what angle does the sun from being up here make the angle of elevation down here. So that might be kind of confusing. So we're going to look at this angle. So from this angle, we'll call it x again. We have the opposite and we have the adjacent. So opposite and adjacent, which trig function do we use? We have opposite and adjacent. Tan, right? So we're using tan again. So tan x is equal to 85, the opposite, over the adjacent, which is 47. Okay, so do some algebra here. So how do we get rid of the tan on the x? You do arctan. Arctan cancels with this side, arctan on this side. So I'm just going to do that out. Tan negative 1, 85 divided by 47. And hopefully this part, by now this should be kind of in your head how to do it really easily. So the angle K will be 61.1 degrees. And then you can write your sentence over here. So the angle of elevation of the sun is 61 degrees. 61.1 because they said to round to the nearest tenth. So, okay, there we go.